Welcome in your math revision. Let's begin. Exercise number 1. In the opposite figure, C belong to BD, AB is 6 centimeter, CD is 5 centimeter, then BC equals what? Since measure angle D is equal to measure angle CAB, so AB is tangent for the circle which pass through the points or the vertices of triangle ACD. From the application of the similarity in the circle, we get AB power 2 is equal to PC times BD. Let BC is X centimeter, so BD is X plus 5. So X times X plus 5 is equal to 6 power 2, which is 36. Remove the brackets, we get X power 2 plus 5x. X power 2 plus 5x is equal to 36. Quadratic equation from the second degree, so its right side must be equals 0. So x power 2 plus 5x minus 36 is equal to 0. Factorize, we get two factors as x minus 4 times x plus 9. So x equals 4 centimeter and x equals negative 9 centimeter. So the second answer is refused. So x equals 4 centimeter. Another exercise. In the opposite figure, AD bisects angle E. BD is 3 centimeter, DC is 5 centimeter. Then the length of AB. AD bisects angle A. AD is angle bisector, so AD bisects PC by the ratio BD over DC, which equals to PA over AC, which equals 3 over 5 from the angle bisector. So we can say AB equals 3m centimeter, AC also equal 5m centimeter. 3m, AC is 5m. We have to find the value of m. Since ABC is right angle triangle, ABC right at B, so from Pythagoras theorem we get AB power 2, which is 3m power 2 plus 8, BC 8 power 2 is equal to AC power 2, which is 5m power 2. So 9m power 2 plus 64 equals 25m power 2. Move 9m to the opposite side, we get 25m power 2 minus 9m power 2 equals 64. So 16m power 2 is equals to 64. So m power 2 equals 4 and m equals 2. Positive or negative 2. Take m equals 2. M equals 2. So AB 3m equals 3 times 2, we get 6 centimeter. Then the length of AB is 6 centimeter. The next, in the opposite figure, AB 7 centimeter, 5 centimeter, 6 centimeter, x centimeter. Find the value of x. Since AC intersect AD at the point A outside the circle, then we know AB times AC, AB times AC equals AE times AD. AE times AD. Substitute, we get, by substitution we get AB is 7 times AC is 12, 7 plus 5 equals AE, which equals 6, times AD, which equals x plus 6. Plus 6. Divide by 6 on the both sides, we get x plus 6 equals 2 times 7 equals 14. So x equals 14 minus 6 equals 8 centimeter. So x equals 8 centimeter. Another exercise, if power the point A with respect to M, circle M, equals power the point A with respect to N, where M and N are two circles, then AM equals AN, the radius length of M equals the radius length of N. No. A lies on the line of intersection of the two circles, also wrong. A lies on the principal axis of the two circles. Yes, the correct answer is D, because any point belong to the principal axis of the two circles has the same power with respect to the two circles. Any point on the principal axis of two circles has the same power with respect to the two circles. Another exercise, the arc length in a circle of radius 6 centimeter opposite to central angle of measure pi over 2 is. We know that theta rad equals L length arc over the radius length. So L equals R times theta rad. R is given 6 centimeter times theta rad is pi over 2. So L equals 3 pi. So the correct answer is 3 pi centimeter. The next, in the opposite figure, area of triangle APD, area of triangle APD equals how many centimeter squares? Here we have two triangles. One of them is APD the required, and the other which is ABC. The two triangles have common vertex. Two triangles ADB and ABC have, or in them, a common vertex. Number one. Number two, the base of the first, which is PD, and the base of the second, which is PC, lies on same line. So we can deduce that area of triangle ADB over area of triangle ABC is equals to the ratio between the base of the first, which is PD, over the length of the base of the second, which is BC. Now we have to find the ratio between BD and BC. Since AD bisects angle A, so from the ratio of the angle bisector we get CD over DB, CD over DB equals CA over AB, CA over AB, which equals 8 over 6, which equals 4 over 3 in the simplest form. So CD take ratio 4 and DB take ratio 3, so BC is 1. So the ratio between BD to DC is 3 to 1. 3 to 1. This equals 3 to 1. So the ratio between area of triangle ABC and the area of triangle ADB equals 1 over 3, or 3 to 1, 3 to 1. That means area of triangle ABD is 3 times area of triangle ABC. We can find the area of triangle ABC, area of triangle ABC equals half times base times height equals half times 8 times 6. This equals 24 centimeter square. So area of triangle ADB is 3 times of area of triangle ABC. This equals 3 times 24. We get 72 because the base of the first triangle is 3 times of the base of the second triangle. So the ratio between area of the first to area of the second is 3 to 1. Another exercise, the range of the function f theta equals 3 sine 2 theta is. You know that sine 2 theta is greater than or equals -1 and less than or equal 1. If we multiply by 3, we get -3 less than or equals 3 sine 2 theta less than or equals 3. So 3 sine 2 theta is belong to -3 and 3 closed. So the range is -3 and 3 closed interval. If one of the two roots of the equation x plus k power 2 minus 6x equals 0 is additive inverse of the other. We know that one of the two roots additive inverse of the other means p equals 0. b is the coefficient of x. b is coefficient of x. But our equation is not in its general form, so we have to put it in its general form. To do that, expand the binomial square to find x power 2 plus 2k x plus k power 2 minus 6x is equals to 0. So x power 2 plus x, take x as a common to get its coefficient, which is 2k minus 6 plus the absolute term, which is k power 2 is equals to 0. Now we can say 2k minus 6, which is the coefficient of x, equals 0. So 2k equals 6 and k equals 3. So the correct answer is C. The next, in the opposite figure, AB times AC equals. Here we have AD bisects angle A. Since AD bisects angle A, so BD over DC is equals to PA over AC equals to 4 over 9. So we can say PA A equals 4m and AC is 9m from the ratio. But AD equals 3 centimeter. AD, since AD equals 3 centimeter, so then we know that the rule of AD is AB times AC minus BD times DC equals AD. The rule which we can find from it the length of AD. So square root of AB times AC, the required AB times AC minus BD times DC, which equals 4 to 9. This equals AD, which equals 3. Move the square root to the opposite side, we get AB times AC minus 36 is equals to 3 power 2 equals 9. So AB times AC equals 9 plus 36 equals 45 centimeter square. So the correct answer is B. The first part which we get, we don't use it in our required to find our required. The next, in the opposite figure, power A with respect to M. Power the point A with respect to M. To find the power A with respect to M, we know that power A with respect to M equals AM power 2 minus R power 2, also equals AB power 2, also equals AC times AD. The one which we will use it is the third rule. So power A with respect to M equals AC, which equals 5, times AD, which equals 5 plus 3, we get 40. So the correct answer is C. The next exercise, the opposite figure represents the curve y equals 3 sine half x. Then x coordinates of the point B. X coordinate of the point B. The opposite figure represents one period of the function y equals 3 sine half x. Period of the function from the graph of the function y equals 3 sine half x. So we have to find its period. To find the period of the function, we know that the period equals 2 pi over half. This equals 4 pi. So B is 4 pi and 0. So the x coordinate of the point B is 4 pi. Another one, the opposite figure AD parallel to BC. Area of triangle PEC 9 centimeter square. Then the area of triangle ADE. First triangle ABC. Triangle EPC and triangle EPA have number 1 same vertex, which is B. Also the base of the first, which is EC, and the base of the second, which is AE, are on same line. So area of triangle EPC over area of triangle EPA equals the ratio between EC over EA, which equals 2 over 4, which equals 1 over 2. So from that we get area of triangle ABC 9, so area of triangle ABE is 18 centimeter square. So area of triangle ABC equals 18 plus 9 equals 27 centimeter square. From the area of triangle ABC, we can find the area of triangle AED because AD parallel to BC, so triangle AED similar to triangle ACB, and the ratio of similarity scale factor equals 4/6, which equals 2/3. So area of triangle AED over area of triangle ACB equals 2/3 power 2 equals 4/9. Since area of triangle ABC equals 27, we get it in 1. So area of triangle AED equals 4 times 27/9. We get 12 centimeter square. High level problem. So the correct answer is 12 centimeter square. The next, AD bisects angle PAC. AB is 6 centimeter, 8 centimeter, 3 centimeter, then the length of AD. To find the length of AD, we have to find the length of DC. From the bisector AD bisects angle A, so CD over DB equals CA over AB. Then CD over 3 is equals to 8/6, so CD equals 3 times 8, 24, divided 6 is 4 centimeter, so CD is 4 centimeter. To find the length of AD, we know that AD equals square root 8 times 6 sine times sine minus 4 times 3. We get square root 36, which equals 6. So the correct answer is C. The sign of the function f, where fx equals 7 minus x, is negative in the interval what? To investigate the sign of the function fx, we have to find fx equals 0. At 7 minus x equals 0, so negative x equals negative 7, so x equals 7. Our function fx is equal to 0 at x equals 7. From the number line, we get fx at x equals 7, fx equals 0. After 7, our function has negative sign, same to the coefficient of x. Before 7, f of x has positive sign, so our function is positive from negative infinity up to 7, open interval, negative infinity up to 7. So the correct answer is A. The next, in the opposite figure, we have AD parallel to BC, also CD bisects angle C. The required is AE over PC over EC equals what? AE over EC from the parallel since AD parallel to BC, we get AE over EC equals AD over DB, proportional parts. But we didn't find AD over DB in our choice. But from the angle bisector, since CD bisects angle C, so AD over DB equals AC over CB. So the correct answer is AC over CB, number C. Another exercise, the number of intersections between the curve y equals sine 3x with x-axis in the interval from 0 to 2 pi equals what? High level problem. The given sine function sine 3x, the required how many times the curve of y equals sine 3x intersects x-axis in the domain 0 to 2 pi. To find that, we have to find firstly the period of the function to draw it. The period of the function equals 2 pi over 3. This equals 120 degrees. That means the period of the function complete at 120 degree, at x equals 120 degree. So the first period complete at 120 degree, but our domain up to 360, so we can complete another period at 240, also another one at 360. So our function has 3 complete periods from 0 up to 2 pi, which is 360. To find the intersection point with x-axis count, we get 1 at 0, 2 at 60, 3 at 120, 4 at 200, 180, 5 at 240, 6 at 300, 7 at 360. So number of intersection, the number of the intersection between y equals sine 3x and the x-axis is 7 times. High level problem. Another exercise, in the opposite figure, x equals. We know that measure angle AED equals half times measure of the arc AD plus measure the arc PC. So 80 equals half times 3x plus 5x. Simplify the right side, we get half times 8x equals 4x equals 80, so x equals 20 degree. So the correct answer is 20. Another exercise in the opposite figure, fx equals ax power 2 plus bx plus c. Then b plus c over a equals. From the graph, we find that the two roots of the function L and M are 2 and 5. The required b plus c over a, this equals b over a plus c over a. b over a is negative sum of the two roots. So b over a equals negative 2 plus 5 equals negative 7. But c over a equals the product of the roots. Product roots equals 2 times 5 gives 10. So b plus c over a equals negative 7 plus 10. We get 3. Negative 7 plus 10 equals 3. So the correct answer is A. The next exercise, 1 minus I all power 12. 1 minus I all power 12 is equals to 1 minus I power 2 all power 6. Expand the binomial square to find 1. 1 power 2 is 1. Negative 1 times I is I times 2, 2I plus I power 2 all power 6. Simplify what inside the bracket, we get 1 minus 2I, I power 2 equals negative 1. So cancel 1 with negative 1 to get negative 2I all power 6. This equals negative 2 power 6 times I power 6. Negative 2 power 6 is 64. I power 6 is equal to I power 2. I power 2 equals negative 1. 64 times negative 1 instead of I power 2 to get negative 64 is the correct answer. So our answer is C. Another exercise in the opposite figure, AB parallel to AF parallel to CD. Then AF is equal to, exercise from the high level. First, let's start with the two triangles AB and ACD. Triangle EAP is similar to triangle ACD because AB parallel to CD. So AE over EC equals AP over CD equals 3 over 6 equals 1 over 2. So the ratio between AE and AC 1 over 2. Now we will use another two triangles. The two triangles AB, the two triangles, EFC and the great triangle ACB are similar. Triangle ECF similar to triangle ACB, also because EF parallel to PA. So EF, which is the required, EF over AB, which is 3 centimeter, EF over 3 centimeter equals 2 over 3 equals 2 EC over CA which equals 3. So AF equals 2 centimeter. So the correct answer is B. Okay, our questions are finished. Thank you.